Now, in problem number 16, this problem requires getting the area of the triangle, and this is an isosceles triangle, minus the area of the circle. So if we work with a triangle, let me draw the triangle. It's an isosceles triangle. See, the apothem is 4. And if it's an equilateral triangle, that means that each one of the angles is 60. So when you cut it, that is 30. So 4 is the short leg. You have the right angle at the base, so which means that the adjacent is the long leg, so it's 4 square root of 3. But since the other piece is also 4 square root of 3, the length of the side would be 8 square root of 3. And the perimeter, it's 3 sides times 8 square root of 3. That gives you 3 times 8 is 24 square root of 3. So that would be the perimeter. Then the apothem is 4. So then when you put that in the formula, it would be 1/2 the apothem times 24 square root of 3. And that gives you 41.57. Then minus the pi, and the radius is 4, so it's 4 square. You put that in the calculator, and that gives you the 32.9 square meters. So next problem, number 17. In problem number 17, it's just a matter of using the central angle, which is 45, out of 360 times pi, and the radius is half of the diameter, which is 4.5. So it's 4.5 square. You just put that in the calculator, and that gives you the 8.0 square inches. So that was number 17. Now number 18. See, for problem number 18, since they're not giving you any measurement, nothing, what you need to do is think about tripling an area. So the area that I thought about was A equals 16. And this is a square. Okay, so if I have the area being 16, and I use 16 because I know that the area of a square is the side square. So when I want to know what the length of the side is, I can just get the square root of that. So the length of the side, if my area is 16, would be 4. And then they're saying, if the area triples, so it would be 16 times 3, so the new area, 16 times 3 would be 48. And again, if I want to find the length of that side, I need to get the square root of that. So square root of 48 is the same thing as square root of 16 times the square root of 3. And the square root of 16 is 4. Square root of 3 stays like that. So if I look at the at both sides, which is this 2, what happened to the length of the side? Well, it's multiplied by square root of 3. So in this case, you just have to work with 2 areas and try to figure it out. What's the length of the side so you can compare the sides? Okay. In problem number 19 is basically the same thing as problem number 10. All you have to do is work out the problem backwards. The area is given, and you want to know what the radius is. So you divide by pi first, and then get the square root of that. And when you put all of this in the calculator, that gives you 9 feet, but it's the radius. Since they want the diameter, you multiply by 2, and that gives you the 18 feet. And that was that problem. 20, everything is given in number 20. So in number 20 is diagonal 1, diagonal 2, or vice versa, half of that, and that was the answer. Now 21, you have to work out this problem. See, this one, what you can say is that if this is 30, and this is the short leg, well, the short leg is half of the hypotenuse. So half of 6 is 3. So that's the height. So is 1/2. The sum of the bases, that's for a trapezoid, is 31 times the height, which is 3. Then just put that in the calculator, and that gives you, did you get 46.5? Because it's 91 and then divided by 2, 93 and then divided by 2 is 46.5 square centimeters. Next problem, 22. In number 22, you need to use the Heron's formula. So you need to have memorized that formula. Make sure you memorize the formula, guys. So the formula is S equals the sum of the three sides divided by 2. And then the formula says S times S minus the first side, which is 6, and then S minus the second side, and then S minus the third side. So S, the sum of the three sides is 46, half of that was 23. Then just a matter of putting it into the formula and plug it into the calculator, and that was it. So for number 23, it says describe the effect on changing, in this case, of each changed on the perimeter and on the circumference. In this case, is a perimeter, and the area of the triangle. If you change all the dimensions, then the perimeter would also be multiplied by whatever the number is given. In this case, it doubles, so it doubles. And if you change all the dimensions, the area would be multiplied by the factor, which the factor is 2, square, and that would be 4. So it's multiplied by 4 or just quadruples, whichever of the two is right.